Welcome to another episode of the Bug Bite, hosted by yours truly, Tech Coach Ralph. In today's episode, we are going to go over the Apple iOS Goto Fail vulnerability that happened around in 2014. So let's get into it and see what happened. All right. So this article is from synopsis.com, and we're going to be talking about the Apple Goto Fail vulnerability. So let's get into it. All right, so let's see what's going on here. All right, so let's start. You may have heard about the not recently for us, because this is almost 10 years ago, but recently publicly disclosed vulnerability in Apple iOS. Let's take a look at the Goto Fail vulnerability details as well as who is affected. All right, so the vulnerability details. As the code at http opensource.apple.com/source, so the URL listed below shows there is a bug in the implementation of the SSL verify signed server key exchange function. Although the Goto Fail vulnerability has been discussed in many other places, let's take a look at it here on synopsis.com, as well as on the Tech Coach Ralph channel in this episode of the Bug Bite. So here we have code, right? We have some code, and here is where the error happens, right? In this little red rectangle here. So they have Goto fail twice. All right. So in this if statement, so if error equals SSL hash SHA1 update, right? And then these parameters inside does not equal 0. So if this does not equal 0, then Goto fail, but they have it twice. So let's see what are the implications of having the Goto fail twice, all right? So it says, the issue is the two consecutive Goto fail statements, although the indentation of the line makes it appear as though both get executed only if the predicate in the if statement is true. The second one gets executed regardless of whether the predicate is true or false. If the indentation is corrected, the problem becomes more obvious, right? So, okay. So here's what I'm seeing, right? When I'm not sure which language this is being written in, but I know in Java, for instance, right? If you do not have the brackets to open, right? If you don't have the brackets to open, then in an if statement, that is, right? So let's say you have if statement, you don't have brackets. It's going to execute the next line as part of the if statement, but then the line after it is not going to be part of that if statement, right? So, and in Java, indentations don't matter like they matter in Python. And if the language that they're writing this in is similar to how the Java's strictness in object-oriented programming is, then the way that it's reading here is accurate, right? Because this if statement only takes the next line. So once it gets here, it's always going to go to this Goto fail statement. Right? Even if this is true and it goes to this Goto fail, it's still going to go to this one as well, because this is not inside the if statement. Right? So since the SSL hash HSA1.update call will generally not return an error, the value of error will almost always be 0 when the second Goto fail statement is executed. And what happens when Goto fail is executed? So this is the fail, right? SSL free buffer signed hashes, SSL free buffer hash CTX return error. All right. So whenever this is being executed, right, or this one is being executed, you're always going to get this return error. All right. The return value, scroll up. The return value of 0 is provided to the caller who believes that the signature verification on the server key exchange message passed. So who is affected by this, right? Everybody running a recent version of iOS and Mac OS X seem to be affected. So this is from like an old version. Like I think they said around like iOS 7 maybe. The bug is in the code that verifies a signature on the server key exchange message in the SSL TLS protocol when a version of the SSL TLS older than TLS 1.2 is used. The code is called from, so this is where the code is called static OSS status and SSL decode signed server key exchange. So this is the code, right? We don't have to get into every line of the code, right? Because this code will only be executed if the ephemeral Diffie-Hellman cipher suite is chosen for communication. Also, as you can see above in the TLS version 1.2 is used, a different version of the function is executed which does not have this vulnerability, right? And the vulnerability, like for instance, I know in like in the IntelliJ or not IntelliJ, but in the JetBrains suites, right? Doing a if you're on a Mac Command D, if you're on a Windows Control D, it's going to duplicate the line. So if they're using one of those softwares, they could have by mistake duplicated this line right here because the way that it's indented, it looks like it was a simple Control D or Command D that created this duplicate code, which was causing all this problem. All right, so let's go back to where we were. Okay. However, this vulnerability enables man-in-the-middle attacks for all SSL TLS connections initiated by affected devices. I'm not going to discuss the details of how the SSL TLS protocol works, but at a high level, here are the steps that get executed, right? The client sends a list of cipher suites that it supports to the server. The server selects the cipher suite it wants to use back to the client. If the ephemeral Diffie-Hellman cipher suite is chosen, the server also provides its certificate and Diffie-Hellman parameters signed using the private key corresponding to its certificate. The client verifies the signature on the Diffie-Hellman parameters provided by the server and then generates its Diffie-Hellman parameter and sends it to the server. If the client certificate is used, this value is signed by the client. The client and the server generates a session key using the Diffie-Hellman parameters. The client and the server exchanges hashes of all handshake messages over a channel protected using the session key. This is meant to protect against man-in-the-middle attackers modifying otherwise unprotected handshake messages in transit. So let's keep going. Let's consider the case where the ephemeral Diffie-Hellman cipher suite is not selected by the server. The attacker can replace the cipher suite selected by the server, leave the server certificate unmodified, and include a server key exchange message with Diffie-Hellman parameters chosen by the attacker. The client will verify the server certificate, but will skip verifying the Diffie-Hellman parameters signature due to the vulnerability discussed in the previous section. So I'll say this, right? In order to make use of this vulnerability, you gotta really know what you're doing. Because first you have to like figure it out, and then you need to you have to figure out there's an actual vulnerability, and then you have to take advantage of it and know how to take advantage of it. So I'm not sure how many people can do that, but I'm sure there's there's quite a few. Probably done. All right, so it says the client will have failed to verify the Diffie-Hellman parameters provided to it were actually provided by the server whose certificate is received. The attacker can optionally also establish an SSL TLS connection with the server and the proxy traffic between the client and the server. The same type of man-in-the-middle attack will work if the server selects TLS v1.2 as well. The attacker can cause the client to fall back to TLS 1.1 where the vulnerability code will be executed. So it's a lot of information about how it can be taken advantage of at the time, right? This is fixed now, obviously, right? But let's find out, how did this happen? So this is an interesting, so continue with the article, right? This is an interesting question. There's evidence of copied and pasted code in several places in the vulnerable file. Good old copy and paste and keyboard shortcuts to duplicate, right? So for example, note the logging statement in the first screenshot in the blog entry. It's clear that the code was copied from SSL decode signed server key exchange to SSL verify signed server key exchange. It is possible that the developer copied and pasted some code on top of some existing code, but forgot to select one line in the copy in the code they were replacing. Right. So let's take a look at it real quick. Right. Let's see if we can see where it was copied. Let's see. Let's see. SSL verify sign key exchange. SSL error log, SSL decode sign server key exchange. Oh, okay. So it looks like what the person who wrote the article is calling out is SSL decode sign key server key exchange. It looks like they're saying it should have said this instead. SSL verify sign server key exchange instead of SSL decode in the log message, and that's how it looks like it was copied and pasted. That's what it looks like they're saying. Okay. So all right, so let's keep going, right? How could this have been prevented, which is what we really, really want to know. There are several ways in which this problem could have been prevented. Let's take a look at some of them. All right, so writing and compiling code. Several people have pointed out the use of Goto in the code. Although this is generally a bad practice, I tried modifying similar code using better coding constructs instead. I never got a compiler error, and the code was not necessarily a lot easier to read. I don't believe that the use of Goto significantly contributed to this problem. Yeah, I don't think so either, right? Looking at the code, I don't think that's what really caused the problem. Because if that one line wasn't there, the code should be working perfectly fine, right? It's because you have this duplicate line and how it's being handled by the language you're writing in, right? So, reviewing code. Manual code reviews are a great way to catch these type of problems. The indentation issue does make the code more difficult to read. This is precisely why whenever I manually review code, I use the IDE to automatically fix indentations before I start looking at it. This doesn't guarantee that the reviewer will catch every problem, but it does make code easier to read and understand. If you perform manual code reviews, I would highly recommend doing this. Oof, that is interesting because when doing code reviews, that would require you pulling in the latest code, doing the format, and then would you push it back up to the repo then? I don't know. That it makes a lot of sense what they're saying. Oh, and then like if there's multiple files being updated, you have to do the formatting on the multiple files. I would rather part of the instructions when pushing up a pull request would be to make sure you format your code before pushing it up, right? Instead of me having to pull it in and having to format it to make sure that it looks right, you should format it and then push up the PR request so that it can be reviewed. I don't know. I don't know about this one, right? It makes sense. It just seems like a lot of overhead to do. But anyways, all right, let's keep going. So testing. If you're implementing security protocols, you need to have test cases that test every step of the protocol. Some commercial SSL TLS fuzzing tools may have test cases for this problem already. If they don't, I'm sure they will in the near future. Use these tools or implement your own. So here we go, right? With unit test and with so I wonder the quality of the unit test, right? Because I would think if you're writing unit tests, right, you want to go through this if statement, you want to go through this if statement, you want to go through this if statement, you want to go through this if statement. When going through this if statement right here, it should have triggered the error because this, even with the indentation and the formatting, right? Here is where the problem lies. So there should have been a test that's going to trigger each of these scenarios, or if we are doing clean code, right? We don't have all these conditions in one method is another option. Because now this method takes path 1, 2, 3, 4, 5, and on 4 is where the error is, right? Or if we're doing test-driven development where you write your test first, and when you run it, right, you fail, you run it till it pass, you fail, you run to the pass. When you get to here, if you duplicated the code, you should be failing, right? When it's executing this method. And you can also maybe extract these into their own methods, right? I don't know. I don't know. This is interesting, right? But yeah, like I definitely agree with the testing aspect of it as a Q engineer, of course, right? You definitely have to. You need to have proper testing in place, and then what was the like so that's in regards to like the dev testing portion of it, right? But what did the Q engineers test, or were there Q engineers to perform the testing as well, right? This like to have a duplicate code to cause this type of vulnerability, that is definitely preventable. All right. So let's go to the protocol definition. So let's see. Do we want to go through this? I don't think this is necessary to review. I don't think we need to go through this section right here to review this bug in the iOS operating system, right? So let's see. What can you do about it? End users should apply patches supplied by Apple as soon as possible. If you have an iOS app, you can use the SSL set enabled ciphers function to disable ephemeral Diffie-Hellman cipher suites on the client side in the short term. We don't need to read this. So this is a moot point at this time because the patch was released and fixed 10 years ago. But I think it was very, very interesting of the testing part through the unit testing and through QA testing, as well as I do like, the part about pulling in the code and formatting it. That is interesting. I don't know. I have to think about that one a little bit more. But well, not this one. It was under the reviewing code part. Fixing the indentations does make it a little bit easier to see, but I think that it would be better if the person who's actually doing the code does the formatting, and that's part of the checklist of submitting a pull request. But to pull in all pull requests and I don't know. It's hard to say. I could see that one going both ways, but the testing part, super important. What were the protocols to test it in place? Were there adequate unit tests? Were there adequate QA tests? Was test-driven development done? So all these questions lie about how this vulnerability, how this bug could have made it out of the development and into a production release when it was just as simple as a duplicate line of code, most likely due to copying and pasting or using the handy Command D or Control D command, So anyways, that is that. Yeah. So that is our episode of the Bug Bite this week. I hope you found it interesting. I definitely found it interesting how a one duplicate line of code could cause so much trouble, but it is what it is. So that is our show for this week. Tune in next week again for another episode of the Bug Bite. But until next time, this is Tech Coach Ralph signing off.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.